In this video, we're going to look at finding sums of geometric sequences. So we're first going to start out by looking at sums of finite. Finite meaning not infinite. That means that we have a particular term that we're going to stop with. And series, the word series, means that we're talking about the sum of a sequence. So if we're specifically talking about a geometric sequence, then the sum of the terms of a geometric sequence would be called a geometric series. So the sum of a geometric series for finite number of terms will be S sub n is equal to a sub 1. Remember, that's the first term of the sequence. It'll be 1 minus r to the power of n. Remember, r is that common ratio, divided by 1 minus r. Okay, when you see S, that stands for sum. So in our example down here, we see find the sum, and we have this expression that contains that notation that we talked about before, that's sigma. Remember, sigma also stands for sum. So we're asked to find the sum of the first 6 terms of the sequence. And remember that the formula that comes after the sigma is the formula that we will use to find the terms of the sequence. So, before we go into the formula that we see appear, and before we even care that it's a geometric sequence, can't I find those 6 terms of that sequence? Let's do that. Let's do the expansion of the sigma notation. Alright, so we have for n equals 1, we'll have 4 times 3 to the 1 minus 1 power. We're going to say plus, remember sigma means sum. We're writing out the expansion, the adding in between the terms. Okay, so that's 4 times 3 to the 2 minus 1 power. Plus, and we'll just go on putting the n value into all of those terms. Alright, so there's our expansion. Let's do a little bit of simplifying of those exponents. So 1 minus 1 will give me 0. 3 to the power of 0 is 1, so that's 4 times 1, so that's 4. Plus 2 minus 1 is 1, so 3 to the power of 1 is 3. 4 times 3 is 12. 3 minus 1 is 2. 3 squared is 9. 4 times 9 is 36. So 4 minus 1 is 3. 3 to the power of 3 is 27. 4 times 27 is 108. 3 to the power of 5 minus 1, so that's really 3 to the power of 4. 4 times 3 to the power of 4 gives me 324. Okay, you're welcome to use your calculator for all of these. 3 to the power of 5, 972. Alright, now if I put all 6 of those numbers into my calculator and add them together, I get 1,456. So we can say that the sum of the first 6 terms of this sequence is equal to 1,456. Now in this case, we did not care if it was a geometric sequence or not. We didn't use any formulas, we just found the 6 terms of the sequence and then added those together. So if the number of terms is small, just finding those terms, adding them together, really don't need a formula. But what if the number of terms that we want to add together gets very large? Then it will be nice to have a formula. This formula only works for geometric sequences. Alright, so let's see what this looks like if we use the formula. To use the formula, we want to know how many terms are we adding together, and that's 6, so our n value is 6. we need to know the first term of the sequence, which we found out was 4. And we're going to multiply that times 1 minus the r value raised to the power of n, which we know is 6, divided by 1 minus that r value. Now what is the r value? Well, now that we have the terms of the sequence, what do we need to multiply by 4 to get to 12? And then from 12 to get to 36, and then from 36 to get to 108. I think that looks like it's a pretty clear 3. So we multiply by a positive 3. So we'll put 3 here and here. All right, we want an exact answer, so we want to be careful to do as much as we can without our calculator. 1 minus 3 gives us a negative 2. 1 minus 3 to the power of 6. Now that's something that you can put directly into your calculator without any troubles. Alright, so in my calculator I'm going to do 1 minus 3 raised to the power. So if I hit the a to the power of b button there, it'll let me change my exponent to be whatever I want. So that gives me negative 728. Alright, negative 728 divided by negative 2. We can put that into our calculator as well. And I get 364. 4 times 364, that gives us 1,456. So we get the same answer doing the long way or using that shortcut formula. So this formula would come in handy if we have a large number of terms that we would add together. So for example, let's say instead of just adding 6 terms of this sequence, we were asked to find, let's say, 20 terms of the sequence. So you may not want to write out all 20 terms and then add all those numbers together. So once you verify that it's a geometric sequence, then you could go up and use that geometric formula. So the sum of the first 20 terms of the sequence would be the first term of the sequence, which is still 4, times 1 minus the r value raised to the power of n, which is 20, all over 1 minus the r value. At the bottom we get a negative 2 again. And when I put 1 minus 3 to the power of 20 in my calculator, I get a very large number. Alright, I'll put this large number divided by negative 2 in my calculator, and I get a positive value. And I'll multiply that by 4, and I get another very large number. So the sum of the first 20 terms of the sequence is a very large number, so it's over 6 billion. So if you're working with a geometric sequence, you can always use this formula to calculate the sum of a finite number of terms. And it becomes especially helpful when the number of terms gets very large. For example 2, we're asked to find the sum of this sequence. Before we attempt to use any formulas, so for example, let's go back up here, this formula here only works for geometric sequences. So before I attempt to use that formula, I want to make sure that the sequence I'm working with is actually a geometric sequence. To do that, we want to verify that we have a common ratio. So we want to find that r value. Okay, to do that, let's go ahead and find the terms of the sequence. I'm going to find, I think, the first 4, and we'll see how it goes. So n equals 1 to find the first term of the sequence. And then I'm going to set n equal to 2 to find the second term of the sequence. Plus, I'm going to set n equal to 3 to find the third term of the sequence. And then n equals 4 to find the fourth term of the sequence. I'm going to stop there. Now, if you wanted to, you definitely could find all 8 terms of the sequence and then add those 8 numbers together. Because we're stopping at the 8th term, this is a finite number of terms, meaning it doesn't go on forever, it actually stops at the 8th term. So you could find all 8 terms and then add them together. But I'm going to stop at the 4th term and put ... to imply that I could continue. And I'm just going to see if I can identify that it is a geometric sequence by finding the common ratio. So the first term, let's simplify that. That would be negative 1/3 to the power of 1, which would be negative 1/3 times 2. So that would give me overall a negative 2/3 for that first term. Okay, the next term, remember I have to do the exponent first. Negative 1/3 to the power of 2, that would be 2 times a positive 1/9. So a negative squared is a positive, square the top, square the bottom, I get 1/9. If I go a little bit further in simplifying that one, think about that as 2/1, multiply the fraction top times the top, bottom times the bottom. Alright, so negative 1 cubed, a negative raised to an odd power is going to give me a negative value. Cube the top, I get 1, cube the bottom, 3 cubed is 27. So that gives an overall fraction of negative 2/27. We'll go one more time. Negative 1/3 to the power of 4. A negative raised to an even power is going to give me something positive. 1 to the power of 4 is 1. 3 to the power of 4 is 81. So that last term is a positive 2/81. Alright, so I'm looking again for that common ratio, if we have one. If this is a geometric sequence, to get from here to here, I have to multiply by the same number as I would have to multiply by to get from here to here, and from here to here, and so on. So what is that? Now you see that these terms are alternating signs, so it has to be negative, because a negative times a negative would have to get me that positive second term. It looks like the top number itself isn't changing, so it looks like a 1. It looks like the bottom number is getting multiplied by 3 each time. So my guess there would be a negative 1/3. And you could test that out. Multiply 2/9 by a negative 1/3. Good. Multiply negative 2/27 by a negative 1/3 and you get a positive 2/81. Now remember, if just looking at it or kind of playing around with the numbers doesn't tell you what that R value is, you can always do the formula. Take a later term. So let's look at the first 2 terms. Take a later term, divide it by the previous term, with 2 terms that are side by side. If you have a fraction divided by a fraction, we flip the bottom fraction, change to multiplication. Okay, the 2's would cancel, 3 goes into 3 once, 3 goes into 9 3 times. We have that negative there, that gives us a negative 1/3. So you can do that with several pairs of terms that are side by side, divide the later by the previous, and then see that you get a negative 1/3. So I am now convinced that I have a geometric sequence with an R value of negative 1/3. Now, what does that mean? Well, that means now that we are allowed to use that formula for the sum of the terms of a geometric sequence when we have a finite number of terms. So that formula is the first term of the sequence multiplied times this big fraction, 1 minus r to the power of n divided by 1 minus r. Alright, so let's use our formula. The n value is the number of terms we're looking to add together, and that's at the top of that sigma notation. We're asked to add the first 8 terms of the sequence together. So our n value is 8. So the sum of the first 8 terms of the sequence will be the first term of the sequence, which we found to be negative 2/3, times 1 minus the r value. And I'm going to put that in parentheses because our r value is negative. We want to make sure that we take care of those two negatives. And also because I want to make sure that I raise the entire r value, including the negative, to that power of n, which in this case is 8. Then I'm going to have 1 minus the r value. I'm going to put that in parentheses again because of the negative. So that's that 1 minus that negative 1/3. All right, now if you didn't have a calculator, we would want to make sure that we find the exact value of this, and we want to make sure that we don't do any rounding. So the first thing I would do is to make sure that I do the exponents first, which is right here. Okay, so if I have a negative raised to an even power, we know we're going to get something positive. 1 to the power of 8 is 1. 3 to the power of 8, now you might want to put that into your calculator, just that part, and you get 6,561. All over 1, let's do this at the bottom, 1 plus 1/3, because two negatives are going to give me a positive. Alright, so let's keep simplifying, making sure that our answer is exact all the way through. We don't want a decimal approximation. So at the top I will need a common denominator between those two fractions. So I'll think about this as 1 over 1. The common denominator would be 6,561. So I'm going to multiply the top and the bottom of this fraction by 6,561. At the bottom we also need a common denominator, so I would give that a common denominator of 3. So that would be 3 over 3 plus 1/3. Alright, so at the top of that fraction we'll keep the same denominator for those two at the top, and then we'll subtract top minus the top, so that gives me 6,560. Okay, at the bottom we'll keep the same denominator of 3. 3 plus 1 gives me 4. Now we'll need to flip the bottom fraction and change to multiplication. Okay, so when I do that, I get, what's that, 3/4? So multiply the top by 3/4. Simplify where we can. So I notice that I'm really multiplying all three of these fractions together. The 3 on the top can cancel with the 3 at the bottom. The 4 and the 2 have a common factor of 2. 2 goes into 2 once, 2 goes into 4 twice. Let's see, these also have a common factor. 2 goes into 6,560. 3,280 times. You're welcome to use your calculator for that. And I think that's as good as we can get that. So it leaves me with a negative 3,280 divided by 6,561. Now you can also, for your homework, you can also put this into decimals very easily, and it'll give you a nice, clean, exact answer, and I'll show you how to do that in just 1 second. And open up that graphing calculator. I'm just going to type in our formula there. Alright, so I'm going to pull up the keyboard. So we want a negative 2/3. Okay, so you see there have a negative 2/3. I'm going to come out of that. I'm going to say times, and then we'll put our fraction in. It's 1 minus, I put parentheses there because you want to make sure that all of this gets multiplied times the negative 2/3. So 1 minus, and I'm going to put that r value in parentheses as well. So that's a negative 1/3. Then I'm going to come to the outside of that inside parentheses there, so on the outside of that negative 1/3, I'm going to raise that to a power. So notice the button I'm using for raising to a power. a to the power of b. So it lets me pick what power I want, and I wanted 8. Now for the bottom of this fraction, I'm going to highlight just what's inside of that parentheses, and I'm going to hit divided by. Okay, so I still have that outer parentheses. All of this is getting multiplied times the negative 2/3. I'm going to do 1 minus parentheses. I'm going to put the negative 1/3 inside. Alright, so we have everything typed in, but you'll notice that I have this decimal value, not a fraction. This is an approximation, and I don't want an approximation. So in your homework, you're going to be asked for an exact value. So if you look up here, there is this little fraction looking thing with a circle around. I'm going to hit that, and that's actually going to give me the exact value in fraction form. So this is not approximated, this is actually the exact value.